Good evening, I Joita. Resuming today's next session, TS15 on wastewater, I would like to invite Dr. Suneel Pandey to chair this session. But before this, I would like to remind a few points to all present here. The participants are requested to mute microphone and close camera. Speakers may be unmuted when requested. Please adhere to the timeline to avoid delay. The presentations for speakers is of 10 minutes. Question answer session will be the end of the session. Questions should be written in the chat box to the specific speakers. The chair individually will rate each presentation on the rating sheet provided to user. Chair kindly write their chair summary of the session with a few key outcomes and present at the end of the session. Filled in the rating sheet and chair summary will be sent to us by email. I would like to request all presenters kindly confirm their attendance in the chat box as I already requested earlier. So please confirm their presence in the chat box so that we can call you accordingly. With the due permission of the chair, we will start our technical session. Dr. Suneel Pandey, sir.
Okay, so good evening, everyone, and sorry, let me switch on the video. Yeah, it's my pleasure, and me along with my co-chair, Dr. Majumdar, who's also my senior colleague at various points, are very pleased to join this session as a chairman for the chairpersons for the session, not getting into gender issues. The session which we are supposed to manage is on the wastewater, and as I see the structure of the session, it is to begin with around 15 minutes. We'll keep it to 12 to 15 minutes keynote address, addressing the issues and challenges on wastewater management for the country, for the developing country, especially for the country like India. And followed by Dr. Majumdar then would invite presenters one by one and give them directions for presentation, and we'll complete the presentation for the session in the given schedule, and accordingly then we'll kind of end the presentation session with the session summary. So for the keynote address, I'll ask Dr. Majumdar to present his view first, and followed by my views on the keynote issues. Dr. Majumdar, please, sir. Sir, you are muted.
Sir, please unmute yourself, sir.
Okay, so good evening, everyone. Is there any specific keynote speaker? Because in the chairman's note, it's not mentioned directly that we have to give the keynote. So we shouldn't, read on someone else's foot as such. So is there any specific keynote?
No, sir. There is not. There is nothing mentioned. But, sir. If you feel like, sir, you can give sir a keynote speech, sir.
Okay. So this is kind of an unorganized keynote speech, whatever we see around us, and because this is an international webinar where so many participants from different countries are there. So I would also like to give a view about what's happening here. Well, friends, it's a pleasure to be here. And wastewater has become a very important issue. And you see, if we look at it across the world, there was a time when from small plants or small facilities, the tendency was to go for bigger facilities and bigger facilities. So in a large town, for example, there would be 1, 2, 3, that's all. Of course, in India's capital town, Delhi, capital city, Delhi, there are 17 so far. but these are very large wastewater treatment facilities. Over a period of time, one has realized that this may not be the only solution. So there is a trend backwards again. So we are again looking at possibilities to decentralize the facilities so that kilometers on of conveyance sewer lines need not be constructed and maintained, which are very difficult, especially if the cities and the towns are not planned right from the beginning. Then putting up a sewer line, especially with hard pipes, it's a very, very difficult task as such. So therefore, there is a tendency again to decentralized to the extent possible, and this is very exciting in a way. So in a decentralized facility, one can look at small clusters, or can look at ward level in terms of municipal jurisdictions, or in terms of a certain zone of a city. So therefore, as per the facilities available, as per the wastewater to be treated and the strength of the wastewater, uh, different kinds of systems can be developed. And particularly if it has to be in a retrospective kind of installation, then it can be very useful, very handy to have decentralized facilities as well. Because to run through a built up town and digging deep and deep, and as you move towards the sewage treatment plant, suppose the sewer line goes 10 kilometers, and with a very small gradient also, if one starts at 1 meter depth, at the end it may go up to 10 meters depth and so on. And in the intermittent places, one has to have pumps to lift up the sewage and again put it at a slightly higher level. So this becomes pretty difficult and tedious. So therefore, this option as such is developing. Therefore, I would like to mention here and uh, place it before you that we should plan as per the requirement of the site, requirement of our city, requirement of the population, and also the kind of water supply which is available. Say, for a normal hard pipe sewer line, 100 to 125 liters per capita per day water supply is required, which again is not easy in every town today. Even in our country, in many places, it's becoming very, very difficult. There are places where water is being brought by tankers, by even rails. So you can imagine that providing 100 liters per capita per day would be a very difficult thing. So therefore, there have been, if we very quickly track the developments of this thing, for the large scale facilities also, different kinds of sewage treatment facilities were developed over a period of time. And initially the aerobic system called ASP, or activated such plant, that was quite popular till the time that around 1979-80 came the UAF and the UASB. So UASB was possibly a very handy thing later on, but it took quite a bit of time. It took almost 10 years to percolate down to the ground as such. But it is very handy in the sense that the energy requirement is very low. So therefore, lots of UASB plants are being made now. And Professor Littinger, who had actually developed it around 1979-80. See, UAF and UASB were developed almost at the same time, 1979-80. And UASB has really been very handy as such. And UASB can also be utilized for decentralized facilities. See, Dr. Pandey is here. They have a system wherein they use this for small biogas plants also. they have a system called team process. So in that also actually USB is used in a biphasic manner. So what I want to say here is, depending on your situation, meaning number one, water supply, number two, the way to get the pipes through, right? And the kind of treatment facility which would be required if it is in a larger facility. So all those things need to be planned. Otherwise, please plan in a smaller way, and it can be a small cluster, even for 10, 20 households, 500 households, 1,000 households. It can be in any numbers. The planning is, it's very flexible kind of system. And at the same time, there is another system called small bore sewer. Again, the hard pipe sewer, their gradient is not changed. They go by only, the same gradient till there is a pump, the sewage is lifted and put at a higher level. Again, they start. But in a small bore sewer, they use flexible piping so that they can negotiate small bends and small undulations. So therefore, small bore sewer also is a very handy companion of decentralized facilities. And I would like to finish with one particular system, which is called DWATS, or decentralized wastewater treatment systems. In fact, around the year 94, 95, we were, we were very much involved in bringing that to India also, develop it. First we called LOMWATS, or low maintenance wastewater system. And then because the word low was not liked by many people, so we changed the name to DWATS, or decentralized wastewater treatment system. So again, decentralized wastewater system, or DWATS, is a very, very flexible thing, a very flexible design. It's not a particular design, but you can design as per the situation. It can be for a hostel of a school or a college. It can be for a colony. It can be for a housing society. It can be for a part of a town or a city. So I'd like to end here. What I've just summarized, that the basic thing is to plan, look at water supply first, look at the land available for getting your pipes, look at the town or city or village, wherever you are going to put the sewerage system, then plan accordingly. And thereafter you will be much more successful, and it will be a very experience for all concerned. Thank you very much.
Thank you,
Dr.
Dr.
Pandey.
Majumdar. Sure, sir. Thank you, Dr. Majumdar. And with this opening, I just would like to add that emphasis now obviously will be also on not only providing convenient decentralized systems with a lesser cost and lesser footprint, energy footprint or environmental footprint, but also on the resource recovery. In the wastewater treatment system, traditionally over the years, we only have been talking of water recovery, water reuse, but time has come. Researchers everywhere are looking at how different nutrients, how different other useful chemicals, in addition to energy, can be recovered from wastewater management while treating the wastewater. So with this, I hand over to organizers. Would you like to call everyone for presentation, or how do we process them?
Yes, sir. With your permission, with Pandey sir and the Majumdar
Sure.
sir permissions, we will proceed to our technical session part.
Sure.
Sir, shall we?
Yes.
Yeah,
Okay,
all
sir.
yours. Yeah.
Okay, sir. The technical session is about to begin. The first presenter of this technical session, Dr. Bindu MallaThakuri. Are you present, ma'am? To present?
Yes, ma'am.
Okay. So I'm making a presenter.
Okay.
General ground rules are we have 8 to 10 minutes for presentation, followed by 2-3 minutes for question and answer. Is that right, Jayata?
Yes, sir. Question answer session at the end of the session is
Okay.
there.
Okay.
And yes, sir.
Okay.
The question answer need to be put in the chat box, and we will
Okay.
verbally. Yes, sir. Um,
How
yes, sir.
many
Please
are there?
continue. Please
9 or
continue,
Okay.
Dr. Bindu MallaThakuri.
Okay. I will continue.
And the next 10 minutes is yours, ma'am.
Okay. Thank you so much.
Okay.
The title of my presentation is Energy Waste to Energy as an Alternative Energy Source for Waste Management in Nepal. Where is the next slide? Why it's not moving? The background, increases in population, rapid expansion of urban municipalities, economic growth increases the solid waste and also the energy demand, especially in Nepal, environmental problem, which is created by waste and public health risks are the major problem. Our country mainly depends upon the traditional energy and imported fossil fuels. Despite there is a link between the waste and energy, Nepal, we are not still practically used, and it is still viewed as inferior. So Nepal's economic and social development is being hampered by inadequate energy supply. Therefore, waste to energy is an alternative energy source in achieving our goals of waste management as well as in energy security. So my research question is, what is the current status of waste management in Nepal, especially like generations, waste characteristics, and disposal method, and what methods of the waste are appropriate in the context of the Nepal? So as we know, like if the solid waste are not managed well, it has a directly effect on the environmental and health issues. So from the healthcare to the constructions and other kinds of the hazardous waste directly effect on the environment. And why waste to energy? There is limited resources in our environment. There is a water shortage, increases in greenhouse emissions, and increases in energy consumption. So why the waste to energy? Is there any solution? So we are hoping using waste as energy, we could some solution for environmental, economic, and in terms of the energy. So there is a recycling principle, for example, reduce, or reuse, recycle, and recovery. In terms of the energy mix in Nepal, the energy, there is a primary energy which is used by the biomass and biomass energy, and secondly, the most of the energy used is focused on the traditional and transportation energy. So this is the some of the current status of Nepal, like some background, physical status, and disposal method. We are about 29 million population with the 40% of the urban area, and then we have around 1,000 GDP. So in terms of the waste generation, we can see about 524,000 tons per year. In terms of the per capita, which is about 4 gram per day, and when compared to the global, it's not that much. And we spend almost $30 for the collection to disposable, and the mostly disposal methods are the landfill. So this is the spatial distribution, how the waste is distributed in Nepal. So there are not much data in the mountain area. So most of the waste are heavily generated from the lowland and also urban areas. And in terms of the characteristics, like other Asian South Asian country. We are also, the organic portion is highest one, which is about 66%, and followed by the plastic is the second major problem, and the paper products. So this is just some of the figure photos I'm sharing how we are doing. So the collection and transportation, basically we are just collecting the all kinds of mixed waste, and then segregate this waste on the landfill site by the manually. And this is just the one of the example of our landfill site, which reflects the condition is very poor. And we do some simply unload the waste, spread, and the very simple soil covering and no other technology. So if we compare the generation in Asia and Pacific, we are not that, we are pretty, actually in terms of generation, we are okay. We are the lowest country among the other, compared to other countries. However, some of the countries like capital Kathmandu and other urban cities generate the lots of the waste. And when comparison, the per capita generation, like Nepal and India is doing pretty good compared to other Asian countries. But the problem is unsound disposable. So when we are about like more than 65% in condition where we disposable our waste in the bad, in not the proper way. And we don't have, unfortunately, no data about the recycling of Nepal. So this is also not good. However, there are very few percentage of the informal recycling and compostings are going on. So we do the waste treatment mostly by open dumping, which is about 45%, and remaining is burning. And we can see sanitary landfill and control is about less than 10%. So I'm just thinking this may be the one of the way to manage the waste. So we divide the municipal waste as organic and inorganic, and organic, general, and the recyclable waste. So general waste, we can treat it with the different technology and produce the gas, electricity, and energy. And with the organic, with the biological treatment, gas and compost. And then the remaining residual is a landfill and for the methane collections. So we have to consider also the economic analysis, especially countries like Nepal, where we are very poor and low GDP. So having incinerations and pyrolysis, both the operation and capital cost is much higher. So we have to, considering the analysis, we have to make some plan. So to summarize, first of all, we must segregate the waste at the source, which is the most essential, and then the suitable methods for Nepal case is composting and anaerobic digestion, and then we can move to the incineration and sanitary landfill. Recovery means the energy extraction from the waste by incineration. We may use incineration for the waste management. However, if we want to have the more energy, we need a more waste. This approach is also problematic. So if reduction, reuse, and recycling do not come ahead of the energy recovery, we may discharge the more waste and combust it. So emphasis goes to the reduction, reuse, recycling, then recovery and proper disposal. So we have to develop our policy mix to implement the institutional arrangement and public awareness, and also behavior changes of the citizenship, our citizenship, and then finally we must have some investment from the private sector to fund the waste and energy for the proper waste management. And this is end of my presentation, and thank you very much.
Thank you, ma'am, for your nice presentation. Please unshare your screen and mute yourself.
Okay.
So we will move. Yes, ma'am.
Okay.
So we will move to our next presenter, Dr. Somakraj Banerjee. Are you present here, sir? Please continue.
Good evening, everyone. I am Somakraj Banerjee from Jadavpur University. and I will be presenting my work on wastewater ultrafiltration and hydrophilicity equipment of polysulfone membrane using polyvinylpyrrolidone. So first we start with what is wastewater. It's a combination of liquid and water transported waste from industrial sources, and it contains organic, inorganic matters and gases. And in this particular work, I will be working with organic matter, that is protein. So I will be working with typical dairy wastewater, and these are the typical characteristics of the dairy wastewater. And the proteins of interest are sedum-albumin, lactoferrin, and lactoglobulin. It works as an antioxidant by protecting lipids from oxidation. So it has importance in food and pharmaceutical industries. So I have chosen polysulfone as the membrane material, which has superior thermal stability, a glass transition temperature at around 200 degrees centigrade, mechanical robustness, and chemical resistance. But it also has some disadvantages, like it is strongly hydrophobic in nature, which limits its permeability in case of wastewater treatment, and poor fouling resistance. So I have tried to add polyvinylpyrrolidone into the system to increase its hydrophilicity, and I have used polyvinylpyrrolidone in different weight percentages to see the changes in the system. So these are my aims and objectives. So the primary objective is modification of the membrane with an additive and characterization of the prepared membrane with liquid-liquid displacement porosity and transition test, and to experiment in a wide pH range to find pH dependency of the membranes and the whole separation process, and preparation of modern dairy wastewater and use it for wastewater treatment application by the selected best method. So the material used are polysulfone of 35 kDa, polyvinylpyrrolidone of 360 kDa, and dimethyl acetamide as the solvent, and deionized water as a non-solvent. And this is the composition given in my membranes. So this is the prepared membrane. The solution was fired in a magnetic stirrer for 12 hours and immersed for 6 hours, and then immersed in DI water with casting and enclaspate with 200 micrometer thickness with using phase inversion method. So now I come to membrane characterization. These are the characterization processes I followed. The first comes a liquid-liquid displacement porosimetry. This is my experimental setup, but it's a dead-end filtration module, and with this I have performed all my experiments. Now these are the SEM images of the three membranes I made, and you can see the finger-like structures in here. The finger-like structures in here are proof uh, of the cylindrical pore structures formed in the filtration layer. Now coming to the now coming to the um, now coming to the results of the LLDB process. The percentage number of pores plotted against pore size, and we can see 27% of pores are around 2.25 nanometer, and pore size ranges from 2.25 to 13 nanometers, and the membranes are applicable for ultrafiltration purposes. These are the graphs of cumulative permeability versus pore size and cumulative pore number versus pore size. And from the table, you can see that the mean average pore size varies, gets reduced as I increase the polyvinylpyrrolidone percentage, and the area of the total area of the pores also increase with the increase in polyvinylpyrrolidone, which indicates that polyvinylpyrrolidone increases the permeability of the membrane. So with increasing PVP percentage in the membrane, the total number of pores are increasing, and in our membranes, greater than 90% of the pores lie in the 2.25 to 4.06 nanometer range. There is a marginal decrease in mean pore size from 2.38 nanometer to 2.28 nanometer with increase in percentage of PVP added. Since the total number of pores and total permeability is seen to be increasing, it can be inferred that the addition of the PVP in higher percentage increases the porosity of the membrane. Now, coming to the compaction factor and pure water flux graphs. And from the table, we can see that the compaction factor decreases with increase in polyvinylpyrrolidone, and the permeability of water is also increasing. The equivalent water concentration also increases, porosity increases, and the contact angle decreases, which indicates increase in hydrophilicity with increase in polyvinylpyrrolidone. So higher amount of polymer additive and lesser time to diffusional exchange in the phase inversion process may be making the hydrophilicity higher. Now, coming to the molecular cutoff determination, a semi-empirical method has been employed in this, where the Stokes-Einstein radius has been used to determine the relations between the molecular weight cutoff and the molecular cutoff of the membranes. So, with increasing polyvinylpyrrolidone percentage, we can see that the molecular weight cutoff decreases. Now we have made a protein separation ultrafiltration experiment, where we have experimented the reusability of the membrane, and we can see, as in the first run and the second run, the pure water flux and the ultrafiltration permeate flux of the protein is almost retained after repeat usage. And in the second graph, we can see the effect of pH in ultrafiltration of BVA, the bovine BSA solution, and we can see with high pH in basic condition we get higher rejection, and in isoelectric condition we get lower rejection, and with increase in the pressure, the flux is decreasing. The flux recovery is found to be over 90%. The rejection is highest at basic condition and high operating pressure, and rejection is lowest at isoelectric condition and low operating pressure. Now we have made a model dairy wastewater with commercial skim milk has been treated and centrifuged to an after isoelectric precipitation, we get supernatant fluid, which after characterization by Bradford as a method, the protein concentrated was found to be 102.5 ppm. And after ultrafiltration of this model dairy wastewater, we found that at pH 4.8, using TS15 membrane, which has the highest polyvinylpyrrolidone percentage, gives 74.93% rejection of total protein at 40 psi. At pH 7, the rejection is 79%, which is higher than isoelectric condition. Steady state flux of 9.7 liter per meter square hour at 40 psi with pH 4.8, and steady state flux higher than that at pH 7 has been found.
Sorry to interrupt, sir. You have 2 more minutes left, sir.
Okay. The conclusion is PVP additive has significantly enhanced porosity, permeability, molecular weight cutoff, and BSA rejection and reusability. And higher weight percentage of PVP increases hydrophilicity. Further increase in weight percent of PVP will not be effective. Wastewater treatment gives 75 to 79% rejection of total protein in case of model dairy wastewater. And value of pH of feed affects the separation phenomenon. These are the further prospects. These are the references. These are my acknowledgements. And thank you.
Thank you, sir, for your wonderful presentations here. Please unshare your screen and mute yourself. With the permission of the chair, we will now move to our next presenter, Dr. Murutza Ali Syed.
Thank you. So, good evening, everyone. I myself, Dr. Syed Murutza Ali from National University of Science and Technology. Muscat, Oman. So today we'll be presenting on our research work carried out on the utilization of agro-waste material as an adsorbent for wastewater treatment. So in our study, the slaughterhouse waste which generated in the Sultanate of Oman was studied using the low-cost adsorbent prepared by using the waste orange and kiwi peels, wherein the slaughterhouse wastewater was treated using prepared activated carbon of orange and kiwi peels using series of batch reactor experiments, wherein the performance of these prepared activated carbon was evaluated in the removal efficiency of various of the contaminants by using various parameters such as dissolved oxygen, chemical oxygen demand, biological oxygen demand, and total dissolved solids, including phosphate content. The percentage removal was determined, and also the experimental data was fitted to Freundlich and Langmuir adsorption isotherms, wherein Freundlich isotherms found to be better fitted for our experimental data. So the background is the waste generated from the poultry industry or in general from the slaughterhouses is increasing with the increase in the demand. Also, this generates a huge quantity of wastewater from these slaughterhouses, which contains several pathogenic as well as non-pathogenic microorganisms. So the direct disposal of this will causes negative impact on the environmental biodiversity. So in the literature, there are several technologies have been reported for the treatment of the slaughterhouse wastewater, including coagulation, flocculation process, and so on, wherein the effect of various factors such as the pH, concentration of coagulants, mixing rate were studied, and also the optimization methods such as response surface methodology were used to optimize the process. The substantial percentage removal efficiency of COD was observed, and also the wastewater was treated using batch sequential reactor system with different types of fibers, biofibers reported. The methodology which is used in our study is methods and materials. The samples collected from the local municipality, slaughterhouses, then the samples were stored at room temperature, and before conducting the experiments, the water samples was filtered to remove the particulate matter, and also the initial parameters before the experiment was measured. So the adsorbents, that is the waste orange and kiwi peels, were collected from the local market, and the parameters, various parameters were studied, including dissolved oxygen, total dissolved solids, and other parameters were studied, which are listed here. For adsorption preparation, the collected fruit peels were washed thoroughly to remove any impurities, then treated with deionized water. Then the samples were dried in order to remove the moisture, and they were ground to the required particle size. They were calcined at a temperature of 250 degrees for about 12 hours to produce the required carbon. Then this was added with the sulfuric acid, and the resulting mixture was kept overnight by refluxing for 12 hours. Then the carbon was filtered, washed with water, and it was heated to remove the moisture content. Then the treated carbon was soaked in 1% sodium bicarbonate in order to remove any remaining traces of acid. Then the carbon was filtered and its pH was determined. Then it was dried and the resulting activated carbon of both orange peels as well as the kiwi peels were stored for further experimental studies. Then the beta analysis was carried out to determine its surface area. In our experiment, the batch experiments were carried out using the prepared activated carbon, and the calculated amount of the adsorbent were added, and the mixture was allowed under constant stirring. The samples were taken at regular time intervals and the parameters were measured. The pollutant removal efficiency was determined in terms of the percentage removal efficiency. So these are our results. The percentage removal efficiency was studied in terms of the contact time. So as we can see that with the increase in the time, the percentage removal of the contaminants were reduced. The parameters which studied here were dissolved oxygen, chemical oxygen demand, biological oxygen demand, total dissolved solids, and phosphate. So the percentage removal efficiency increased with the increase in the contact time. So it was considered for 3 different time durations.
Sorry to interrupt, sir. You have 2 more minutes left.
Okay, sir. Right. So percentage removal efficiency and contact time also studied for both the activated carbon of orange peel as well as the kiwi peels. Then the adsorbent dosage was studied for different concentrations of the adsorbent. Okay, so as we can see, this percentage removal efficiency increased with increase in the adsorbent concentration. Then the samples, the experimental data was fitted for Langmuir and Freundlich isotherms. So the results are presented here. So in the final concluding remarks, both the activated carbon samples of orange peel as well as kiwi peel were prepared, and the collected water samples was treated using the prepared adsorbents, and it was observed that the performance of activated carbon of orange peel was better than the kiwi peels, okay, activated carbon kiwi peels, and the percentage removal in terms of their percentage removal efficiency of various parameters studied. Also, the experimental data was fitted to Freundlich and Langmuir adsorption isotherms, and their constants were evaluated, wherein the Freundlich isotherms was found to be slightly better fitted to our experimental data. So these are some of the references. With this, I would like to thank all of you for your time. Thank you.
Thank you, sir. Thank you for your wonderful presentation here. Please unshare your screen and mute yourself.
Sure.
With the permission of the chair, We will now move to our next presenter, Dr. Rishiraj Verma. Dr. Rishiraj Verma.
Hello. Yeah, I'm present.
Okay, sir. You are the presenter now. You can present your slide, sir. Please share your screen.
Yeah.
Yes, sir. Please make it full screen. Yes, sir. This is okay. Absolutely. Now the next 10
So,
minutes is yours, sir.
yeah, thank you.
Please continue. Please continue, sir. Yes.
So good evening, good evening, everyone. I'm Rishi Raj Verma. I'm an undergrad student at BITS Pilani Hyderabad campus. So as a part of my academic project, I worked on a project titled Modeling Steady State Performance of MBBR Treating Municipal Sewage Water. So So, as we all know, wastewater is any water which has been contaminated by the human use. The major resources include household, industrial effluent, or a mix, or it can include mixture of both also. So, wastewater treatment uh, is is fundamental duty of our society, as it has many advantages. To share some, one of the reason can be it leads to water restoration in our water cycle, and it also leads to resource of resource recovery, like nitrogen, phosphorus, etc. So as a part of my project, I developed one model which can be used in treatment of water, and for developing that model I used one software named GPSX, which is developed by Hydromantis company. And uh, uh, using GPSX software, we can design various wastewater treatment plant model, and this software is used in industries also. So the access was provided to us by Hydromantis under educational license. So so um, um, uh, moving bed biofilm reactor is an economically solution offered for wastewater treatment if the bulk of the pollution load must be disposed. So MBBR system consists of an activated sludge aeration system where the sludge is collected on recycled plastic carriers, just recycled plastic carriers, generally HDPE, high density polyethylene, and these carriers have an internal large surface uh, for optimal contact of water, air, and bacteria. And these bacteria activated sludge grow on in the internal surface of the carriers, and eventually when the wastewater comes in this tank, it breaks down the various organic matter present, and which and then further the water is sent to the clarifier tank for further tertiary treatment or for release. So MBBR process can be used for variety of different applications to attain the desired results depending on the quality of wastewater and discharge regulation. So my project so our project here included determining those parameters on which we can or by which we can increase the efficiency of the MBBR system. So this is the methodology that we used. We use GPSX software for creating various simulations of in various various characteristics of incoming wastewater, various aeration rate, and all. So this is the working. This is the table by which we can enter the various characteristics of wastewater into the GPSX software, and here you can enter various characteristics like concentration of urea, concentration of MgCl2 as per your requirement. And side and this is the working window of GPSX software. On the left hand you can see various by which we can create the model, and on the right hand side top you can see two windows. One is modeling, second one is simulation. First one is used to create various models, and second window is used to simulate the various results using the desired as per as our desired output. And so this is the model which we used in all our simulations. So here you can see this is the incoming wastewater, followed by the grid chamber, followed by MBBR system, then for secondary treatment or clarifier, and then sludge is removed, and the wastewater is released into the stream, into any water stream. So MBBR gives us two different methods, two different aeration methods. One is diffused air method. Second one is mechanical aeration method. First we will discuss which. First, we as a part of our project, we try to find which method using simulation, which method is better, whether diffused air method or mechanical aeration method. So diffused air method is diffused air method consists of small diffusers present in the bottom of the tank, through which air bubbles are released into the tank, and it has complete mixing from top to bottom, and it has low maintenance cost, but it is prone to greater susceptibility and fouling, and it is less effective in harsh environments. Harsh environments here refers to various presence of various other chemicals. So as a part of our project, we simulated various results, and we obtained this result. Like with increase in the aeration rate, biofilm mass decreased, and similarly, when we use the DO controller, more or less same biofilm mass was produced at different airflow, but it was significantly less than the entering airflow method. And similarly, then we use entering KLA method for specific oxygen transfer, and then we observe the similar trend. And coming to the mechanical aeration method, mechanical aeration method is a conventional system which includes a rotating shaft using physically or using a generator. So it has strong mixing and oxygen transfer, but it has lower aeration efficiency, and it gives very unpleasant odors. So so again we simulated various aeration rate, and we saw how biomass is producing, high biomass is producing, and we observed that diffused air method was came out to be better as compared to any other method. So at this part we concluded that diffused air method is better than any other method for using in MBBR. And then from further this point, we used only diffused air method for all other simulations. So
Sir, sorry to interrupt, sir. You have 2 minutes left.
Sir, hello, excuse me.
Thank you, sir.
Hello.
Hello, sir.
Yes.
Sir, you have 2 more minutes.
Yeah, sure, okay. So we observed various results, and we saw that there was no effect on COD, and similarly nitrogen removal was increasing as soon we observed as the aeration rate was increasing, and similarly for total suspended solid and volatile suspended solid, it was decreasing with increase in aeration. And so coming to the conclusion part, we can say that aeration method finding was found to be the most accurate, and diffused air system is the best to use in MBBR, and the COT demand does not change as simulated because of some external factors, also maybe due to denitrification. So the future aspects of this project can be the findings can be verified using the actual lab experiments, and more complex variations can be introduced into the MBBR system, like to obtain various correlation between various microorganism and the pollutant content. And these are the selected references that I referred. And I would like to acknowledge Hydromantis company for providing us with the software license, and BITS Pilani Hyderabad campus for all other necessary resources. Thank you.
Thank you, sir. Thank you for wonderful presentations here.
Go ahead.
So, okay, sir. Please, with the permission of this chair, we will moving to our next presenter, Dr. Nilofer Nisha Zahir. Are you present, ma'am?
Yeah, ma'am, I'm present.
Okay. So we are making a presenter. Your presenter, ma'am. Please share your screen and start presenting. Please make it full screen, ma'am.
Whether my screen is visible?
Yes, ma'am. It is visible.
Okay. Okay, thank you. Good evening,
Next 10
everybody.
minutes is yours.
I'm Nilofer. Okay, thank you. Good evening, everybody. I'm Nilofer Nisha, PG scholar from the Department of Renewable Energy, Gandhigram Rural Institute, India. Here, I'm going to present my academic project, which is about recovering water from textile effluent using solar dryer by implementing renewable energy technologies. Due to rapid urbanization, environmental pollution is reaching its peak. At the meantime, human well-being and their activities are also affected by the development of industries. Nowadays, we are running towards sustainable energy or processes which are sustainable as the world is on the mere edge of environmental safety. One such major problem which every country facing was water-related issues, that too mainly for the availability of clean water. Now, in India, the government is showing more interest and spending huge amount of money for cleaning and conserving the water bodies. Here, in our country, India, textile industries contribute highly on the economic development, and on the other hand, it creates more environmental pollutions. Our focus is to convert wastewater coming out from the handloom dyeing units into the recyclable water using renewable energy technologies. And also, we are investigating the feasible ways of moisture recovery from the solar drying process. What's the problem we are facing? Fresh and clean water is a limited resource. The need for fresh and clean drinking water is increasing rapidly. It is estimated that many Indian villages are facing the problem of contaminated water. As our focus is mainly on textile industries in India, we started looking in detail about the stages of operation. Water plays a vital role in textile industries, and their requirement is huge in varied processing. They include bleaching, dyeing, printing, and boiling. 38% of water is consumed in bleaching process, 16% in drying, 8% in printing, 14% in boiler, and remaining 24% for all extra activities. Textile drying is a popular environmental unfriendly industrial process because they create colored wastewater that are greatly contaminated with dyes, textile auxiliaries, and chemicals. Those wastewater can be toxic to marine organisms due to the existence of metals, chlorides, and breakdown particles of dyes. Textile industries symbolize central environmental trouble because of the high water consumption. Textile effluent is a cause of significant amount of environmental degradation and human illness. Here is how we implemented the renewable energy technologies in our project. We used solar drying unit. The solar dryer works based on the principle of the greenhouse effect. The short wavelength radiation from the sun enters into solar dryer, drying glazing, and is converted into heat. This heat is used to evaporate the wastewater from the handloom dyeing units, while the remaining dyes get deposited at the bottom surface as sediments. This dyes can be further used for handloom dyeing units. As the water is evaporated, it gets condensed in the solar dryer unit. It requires some special arrangements to collect the condensed water from the dryer unit. It is the solar dryer unit in our university where we performed all our studies for this work. Its construction is very similar to the construction of polyhouse. TGA is an analytical technique used to determine a material's thermal stability and its fraction of volatile components by monitoring the weight change that occurs as the sample is heated at a constant rate. We performed TGA of textile effluent to study its thermal behavior. The shape of the TGA curve normally depends on the environment and the degradation reaction of the effluent. It is clear from the graph as the temperature increases, there is a gradual decrease in the weight of the sample. From the solar dryer unit alone, we cannot get fresh water as such. As the water gets evaporated, it is condensed and collected at the top of the dryer unit. As I already mentioned, it requires some special arrangements to recollect the condensed water from the dryer unit. For that purpose, a heat exchanger can be installed outside the solar dryer and is connected to an air extractor which ejected the vapor produced during the process. It's a planned future work. We have planned to extend our already existing solar dryer unit in our university with the heat exchanger at the backside of it. In that, we will be attaching air extractor, heat exchanger, condensate receptor and a refrigeration system. Then coming to the conclusion, a small industry like handloom textile and dyeing unit, the wastewater generated is less in quantity and the existing technology is not cost efficient for the treatment. It can be seen that effluent loses water steadily from 50 to 60 degrees Celsius. This temperature can be achieved in the solar dryer unit. Thus, we can see that wastewater can be recycled and the water obtained can be reused for multiple purposes, thus minimizing the usage of fossil fuels. At last, the objective of setting up heat exchanger was to condensate the vapor produced while collecting the textile water inside the solar dryer. Here on this occasion, I would like to thank my professor, Dr. V. Kribakaran, Director and Head of our department for his guidance and support towards this work. Then I would like to thank this 10th International Conference on Sustainable Waste Management towards Circular Economy for creating this virtual platform for the presenters to participate and present. Thank you.
Thank you, ma'am, for your wonderful presentations here. Please unshare your screen and mute yourself.
Hello, good evening.
Okay, sir.
Myself Tanya from ISWMAW. Since we have done with the presentation session, next we are moving to the question answer session. We do not have any question in the chat box, so I would request the chairs, if they do have any questions from the presenter or any presenter having any question, please address to your speaker. We can go ahead with that. So sir, no response means no questions. So sir, I am handing over. Yes, sir.
Dr. Majumdar, would you like to start?
Okay, so I think we can briefly comment about the presentations which have been made. What we could do is maybe I'll, for example, we'll take one by one, and maybe then I'll speak one or two sentences about the paper as to how they were, what they, how important they were, etc. And then you can add, and then we move to the second paper. So there are altogether 5 papers only, so it won't take much time, right? So I'm starting like that. Is it okay, Dr. Pandey? Hello.
I'm fine with it, sir.
Okay. So we had 5 presentations. They were, all of them were quite interesting and very useful. And I'm very happy that young young presenters and young researchers. They have tried their level best to make presentations here, which were very useful and interesting. If we start with the first presentation was from Bindu MallaThakuri from Nepal. So this was about renewable energy from municipal solid waste. He gave a wide view of the situation in Nepal. I was while listening to her paper, I was just remembering about my work there, because I had been a consultant from ADB in Nepal for I think about 2 or 3 projects, and these were on solid waste management, organic waste management, and so on. So her paper was also quite interesting, and she had given a very wide view. But of course, Nepal actually, I think, requires a lot of work, and there is a lot of possibility, which I felt then and which I felt again while listening to Bindu MallaThakuri's paper. Thank you very much, Bindu Malla, and it was a very interesting paper. Dr. Pandey, would you like to say something about her paper? Hello. Oh, I think Dr. Pandey has muted himself.
Yes, sir. I'm fine with your observations, sir.
Okay, so we now move to the next one, Somakraj Banerjee, who presented about ultrafiltration with polysulfone of wastewater. They have done with dairy water, and this is again very, a very important subject, very useful research, because of course it's in a very nascent stage. We could see the, the efforts and the results and the the trial and errors of the researcher. But I'd like to say here to conclude that this was a very useful research, and one needs to develop indigenous membrane for different pore sizes, and from that point of view, this kind of work is very important, right? So Dr. Pandey, your observation?
So yeah, I mean, this was very interesting presentation, and also if there's a possibility of, as the presenter showed, that there's a possibility to recover water on one side, but also albumin protein, and if that can be removed and used at some stage, because anyway, I mean, providing proper nutrition in developing country to all, whether they are human beings or cattle, is always a challenge. So that would be interesting possibility coming out of this paper, sir.
Good. Then we had the third presentation from Shahid Murtaza Ali from Muscat, Oman. Again, this was a very promising paper, utilization of agro-waste for as an adsorbent for wastewater. They had actually used chicken slaughterhouse waste treatment. And again here, it's a very important one and a very promising one, because if this kind of agro waste or even solid waste as such, there is market waste basically, the peels of orange and kiwi.
Kiwis.
They have found that the carbon which they have extracted or prepared from this was used for adsorption in a very potential manner. Of course, a lot more work needs to be done on this, but I would say that this is very interesting, and there is a lot of good potential for further development on this project. Dr. Pandey.
So my little caution here is that the present activated carbon preparation process involves a lot of chemicals, sulfuric acid conditioning, then and more chemicals you use for producing activated carbon, more waste you have to manage in the pre-processing stage itself before, I mean, it can be used for wastewater treatment. So I mean, the cost of production at some stage will have to be always seen, because there are chances that commercially available activated carbon might be much cheaper than carbon which you produce here.
Right.
So
No, I think
that
you
was
are very
one
right.
observation.
Apart from the cost, the toxicity of the particular chemicals, their disposal
Yes.
after the carbon is extracted, that would remain an issue which needs to be tackled. So I think
That will be.
yes, Syed Murtuza Ali would take care of this. Thanks. And then we come to the fourth one, which is a presentation from BITS Pilani by Dr. Rishiraj Verma. So this was about modeling steady state performance of MBBR while treating the municipal sewage. And they have used Hydromantis GPSX for the modeling. I think this is very interesting, but I feel again that a lot of more work has to be done to really make it useful for actual purpose. Dr. Pandey.
Yes, I mean, I agree with you, because one thing was not coming out very clearly is if the inference cannot be drawn out without use of model on the diffuser's choice. So, I mean, a paper has to clearly spell out what is modeling contributing here in the conclusions which are drawn.
Right. Actually, a lot of work has been done. I mean, if we set aside the modeling issue, a lot of work has been done through the mechanical aeration versus the diffused aeration. And usually the smaller facilities, they go for diffused aeration, whereas the larger ones go for mechanical aeration to make it stronger and more forceful. But here, as you said very rightly, one has to see what is the particular contribution of using the modeling route as such. So I think the researcher would look into this and work further. The fifth and the last presentation was made by Nilofer Nisa Zahir. This was about recovering water from textile effluent using solar dryer. This again is a very very important topic, as she herself said, from the environmental issue, from the water use issue, from the energy use issue or electrical power use issue. The issue of textile effluent, this remains a very important one, and I felt this is promising, but I think a lot more needs to be done to make it actually useful. And Dr. Pandey, I think you'll have suggestions. You have also worked on textile wastewater. So Dr. Pandey.
Yes, basically the problems which were faced by Tirupur cluster, they also wanted to go for RO based or UF based or solar water recovery because of orders by High Court making it mandatory. But there are challenges, and what do you do with the residue which you are left with? And if you can't use it back again in dyeing process, which in all probability you can't, then what do you do with the residue? You are recovering water, but you are left with hazardous waste, and that problem also needs to be seen in totality.
Good. So overall, we had a very interesting presentation, and
yes,
I would like
to interesting researchers. So especially the last one is still not completed research, so it will take some time before we get full data on this, and then it will be. I mean, I think it will be better to judge.
And these have huge potentials, and I was very happy to be with these young presenters, and I hope they would have a long way to go on a very interesting research path. So thank you very much, all the presenters. Now over to the
thank you, Dr. Pandey, and thank you, Dr. Majumdar, for your remarks. Now I request all the delegates to open your camera to take a group photo.
Thank you, Professor Dr. Majumdar and Dr. Pandey, for your contribution as the session chair, and I was listening throughout. I mean, I have 3 microphones with me for 3 halls. I was just hopping. So in that way, it was really interesting. And at the end, your input as session chair will definitely help the speakers as well as the researchers. So that is more important. And Dr. Majumdar is the first time in our session and in IconSWM. So I am really pleased that you are here. Pandey ji is an old person in IconSWM because he has been working with Icon for a long time. But I am very happy that we could get you. I mean, of course, Dr. Pandey has spoken to you also. So that's great. And thanks to all the participants for your very nice and deliberation on different research work activities. It's good. Keep in touch with ICON, and we wish that in 2021 we will physically meet for the conference. That is more important. Okay. So
now it's time to wrap up the second parallel session of second day of 10th ICON SWM-CE 2020. We have 2 more days with several technical and special sessions. Tomorrow we will meet again at 11 a.m. with the same link for this hall. Till then, stay safe. Good night from India. Thank you.
Thank you and good luck, everyone.
Thank you, chairs and all the presenters. Thank you. A very good night.
Thank you, sir.